Let's take a quick walk together through the air leakage metrics tool. This is both a RedCalc free tool and a RedCalc Pro tool. We call this a solve all tool because you can solve for all of these results at the bottom by just entering one input in the bottom section of the tool and 2 or 3 in the top section. You click the radio button for the metric that you wish to enter, and it gives you corresponding leakage values for all of the other ones. Quite an amazing tool. Usually there's no reason to enter the surface area at the top of the tool. I'm going to take that out right now, click outside of the box, and you see that the only corresponding metric that goes away is leakage at 50 pascals divided by the surface area. I'm going to put that back now so I don't forget about it. Click outside the box like that. So up top in the top section of the tool, you would enter floor area, volume, and surface area only if you are interested in leakage at 50 pascals per surface area. And as with all of the RedCalc Free and Pro tools, if you click on a label either for an input, black font, or a result, blue font, it will give you what we call pop-up help. You engage it like this and then get rid of it by clicking again. Let's now look at a little more detail at the inputs in the top section of the tool. For the floor area, we have 2,500 feet. We're assuming this is a 2-story house. The volume is that amount times 16 feet of height. I've used math on the fly here. Remember, it's a 2-story house. Each floor is 1,025 square feet, so I have multiplied that times 2. So we have 2 times 1,025. And then we have that quantity times 8. This is math on the fly. If I click outside of the box now, it will give me the result. Then for the surface area, which you only need, remember, for this metric down here, if you were interested in it, this is what PassiveHouse uses for their air leakage metric. If we come back up here to surface area, I've used math on the fly here. What I've got is the one side of the house. The house is 40 feet by 25.5 feet. And then we also have to include the floor, and we have to include the ceiling. So we have the floor of 1,025. We have the ceiling of 1,025. We have the sides of the house, 40 plus 40 plus 25.5 plus 25.5. And each of those sides is 16 feet tall. So if I click outside of the box, what I get is 4,146 for the surface area. I recommend to you that you leave the pressure exponent at the default value of 0.65. Let's look at a few of the air leakage metric values, and I also want to let you know which my favorite one is. Remember that all of the answers down below, except for the entered one, the leakage at 50, which is CFM 50, all of those are based upon the items that we put up here at the top, which are primarily the dimensions of the building we're looking at, except for the pressure exponent, which characterizes the leakage of the house. As I've already said, it's a good idea to leave that alone. The one I think we're all most familiar with down here is the leakage at 50 pascals. That's the same thing as CFM 50 leakage. So I've said that's 1400 CFM 50. Now, some of you might have heard of, gee, if you take the CFM 50 and divide it by 10, it gives you the approximate leakage area in the envelope. What that actually is the equivalent leakage area, or the EQLA. Notice here that that is 147 square inches. That's not quite 10% of a CFM 50 of 1400, but it's very close. It's actually more accurate than dividing by 10, but that's where that comes from. Some of you, especially if you are constructing new homes, you might be very familiar with the I codes, the International Energy Conservation Code specifically. The most recent years of that code for southern climates require an ACH 50 of 5 or less. For this house, a 1400 is just a little bit looser than that, so it would not qualify. Where I live in Maine, in a northern climate, that value is 3. That's already entered for me. Now notice when I entered that before, and when I click on that as the input, I can see that the corresponding CFM 50 for that house is 820. So I would have to make this house significantly tighter to qualify under the International Energy Conservation Code in Maine or other northern climate state. Now, my favorite metric is the leakage at 50 pascals divided by surface area. This is the value that is used by PassiveHouse USA. Now, let me tell you why. If you look at leakage at 50 pascals, or CFM 50, there is nothing in this metric having to do with the volume of the air in the house or the surface area. In other words, there's nothing that tells you the size of the house. So it's very difficult to compare a bunch of CFM 50 values because you have no idea of the size. Now, if we use, on the other hand, the ACH 50, we're in better condition because ACH 50 requires the volume to be used. So now we have a better idea and we can better compare a large house to a small house, but there's still a problem. As houses become bigger and smaller, the surface to volume ratio changes, and where does the air leakage occur? It occurs in the surface. So ACH 50 can give us a slightly erroneous answer. Also, worse yet, it can lead us in the wrong direction. So this one, the leakage at 50 pascals divided by the surface area, as I said, this is what PassiveHouse USA uses, and this is their standard right here, 0.05 for the value, and you can see I entered that there, come up here, and see that the CFM 50 that corresponds to that is 207 CFM 50. You can also see what the ACH 50 is that corresponds to that. So I think in the future we're going to see leakage at 50 pascals divided by surface area. Another way of saying that is CFM 50 per surface area. That will become a more common metric, and I think it's the best one out there.